Alright, this is Algebra 2, Lesson 5.8. We're going to be solving quadratic inequalities in a couple different ways. So the first one will be on a number line. Now, there might be times where you see this portion here factored. It might be in the standard quadratic form. So in this case, it's already factored for us. Otherwise, we'd have to factor or solve it in some way. So for this one, since it's already factored, what I'm going to do is I'm going to take each one of these parts and set it equal to 0. So we're going to have x minus 6 equals 0 and x plus 2 equals 0. So I solve for x, I get x equals 6 by adding 6 to both sides. Here I subtract 2 and I get x equals negative 2. Now, both of these points, 6 and negative 2, go on the number line. I'm going to put them above so you can see it better. Now, the way I choose whether or not to, say, draw arrows over here and goes out, or a line between, is by looking at my inequality. Since it's less than, it's an and statement, and I shade between. Remember that from before. We know I think it was with absolute value inequalities. If it was less than, you'd shade between. If it's greater than, then you'd shade on the outside. So since this was less than, we shade in between because it's an and statement, and is between. All right. Now, for this one here, we need to first factor. So when I factor this, I wanted to, let's see here, multiply the negative 15, and I wanted to add the negative 2. Well, my two factors would be negative 5 and positive 3. So I'm going to have x minus 5, x plus 3 are greater than or equal to 0. And then I'm going to set each one of these parts equal to 0 and do the same process as before. So you get x equals 5 and x equals negative 3. Plot those both on here. Now this time it's shaded because we have greater than or equal to. So instead of being open, we need to shade them. The next part, since I have greater than, what I'm going to have is shading away from each other. So I draw the arrows outward rather than in between. In between is an and statement, less than. Out is greater, so it's an or statement. Alright, we can't forget about the ones that you guys always seem to have trouble with. Here I only have two terms. So I look for what's in common between the two. Okay? I notice that I have a 4 that I can divide from both and also an x. So I can get 4x times x minus 2. Now that's in factored form. So there's the factoring where you're left with two binomials like we had in the last one. And there's also GCF, which is this one. And a lot of times you guys seem to mix it up or you don't realize what you can do here. This is actually supposed to be one of the easier types of problems. So I'm going to set both these factors equal to 0. 4x equals 0. And we're going to have x minus 2 equals 0. When I solve for x, I get x equals 0. And I also get x equals positive 2. So I can plot both of those, and it's going to, again, well, this time it's going to be open, because there's no equal sign here, so it's just strictly greater. And since it's greater, it's an or statement, and my arrows will be going outward. Alright, first thing I'm going to do is I'm actually going to change this problem. We're going to make this minus 3, because I don't like how it works out. It doesn't really fit on the graph. So, in order to graph this one, graph the solution, first thing I'm going to do is I'm going to factor it if it's factorable, because then I can find my x-intercepts and it's a little easier to graph. I don't have to do the t-chart and all that stuff. So we have y is less than, and I'm going to have two guys like this. And when I go to factor it, let's see here, I have to multiply to negative 3 and add the negative 2. Well, that would be negative 3 and positive 1. So x plus 1, x minus 3. Alright, I'm factored, I'm in business. Multiplies to You double check it. Negative 3 and 1 multiply to negative 3, and they also add to negative 2. So we're good. Now, if I solve these for x, I set them equal to 0 and I solve for x, I'm going to find my x-intercepts. Okay, so whether I ask you to solve for x, or if I ask you to find the x-intercepts, or the zeros, that all means the same thing. I'm setting the factors equal to 0 and solving for x, or using the quadratic formula, or whatever. So I'm going to get x equals negative 1, x equals 3. So if I plot those, I get negative 1 right here, and I get positive 3 right here. So I know that my vertex has to be somewhere in here. Okay, it has to be somewhere in between them, right in the middle. So my x-coordinate is going to be 1. So what I can do is I can plug that 1 into my original inequality and solve for y. So when I do that, I have 1 squared minus 2 times 1 minus 3. I'm going to get 1 minus 2 minus 3. So 1 minus 2 is negative 1, minus 3 equals negative 4. So my vertex is at 1, negative 4. And there we go. So those are my 3 points, and I can graph it. Now, let's pay attention here. We have strictly less than. So that means that it's going to be a dashed line. Just like this. And then comes the shading aspect. So what I need to do is I need to shade either in here or on the outside. Well, since it's less than, it's going to be below the line, or below the parabola. So I'm thinking below. I usually like to look at the vertex. I say, okay, below there. So what I'm going to do is I'm going to shade below the vertex. Well, that's also everywhere out here as well. So everything outside of the parabola gets shaded. If it were greater than, then I'd be on the inside here. Alright. So you just got to think about it, and if it's less than, you go below the vertex. If it's greater than, you go above. And basically shade inside the lines, like we're in, first grade. Alright. So for this one, same idea, but looks a little different. It's only a binomial here, but I noticed that we have x squared and we have 9. Those are 2 perfect squares. So the way I can factor this one is pretty easy using one of those quicker tricks that we had back when we were doing factoring. So we have x minus 3 and x plus 3. So now if I solve for x, I have x minus 3 equals 0, x plus 3 equals 0. I get x equals 3 and x equals negative 3. So my 2 points are right here and here. And I know my vertex is going to be somewhere in between, which would be 0 for my x. So if I plug 0 in for x, I get 0 minus 9. So I have negative 9, which we'll say is somewhere down here. I know it's not quite accurate, but it'll do for what we're doing here. And now I can connect the 3 points. And I know once again that I'm going to have a dashed line because it's strictly greater than. Alright. So there's my parabola, and since it's greater than, I look at my vertex and I say, okay, well, what are the values that are greater than? Well, that's up in here, so I'm going to be shading all of this area up in here. All up in here. And there you go. Alright, so this one's in vertex form, but the first thing I'm going to do here is I'm going to change this 9. Let's make this 9 a 4 instead, just so it'll fit on the graph better. So, first thing I can do is I can find my vertex from this one because it's in vertex form. I look at this spot here and this guy here. Well, I know that the sign needs to change when I pull that out, so I'm going to have 1 for my x-coordinate, but then this one stays the same. It's negative 4. The sign does not change for that one. So I can plot that point. 1, negative 4. There you go. There's my vertex. Now, to find the rest of the points, I'm going to make a t-chart. And we can use the t-chart anytime we want. Alright, so we had 0, let's see here, we have 1, negative 4 here, so I'm going to pick 0 and 2 for my other points. When I plug those in, see here, if I plug 0 in for x, I get negative 1 squared minus 4. That's going to give me 1 minus 4, which is negative 3. If I plug 2 in, I get 1 squared minus 4, so I get negative 3 once again, which makes sense. It should be like that. You should get the same thing. Alright, so those are our 3 points. I'll connect these with a solid line this time. Reason being, it's less than or equal to. So you have to have a solid line when it's possibly equal to. Since it's less than, remember I look at my vertex and I'm going to shade below that and anything else that's in this same area, which means I'm not only shading right here, but all on the outside of the parabola. Remember, stay inside or outside the lines. Alright, do not cross. First grade rules. Alright, and there you go.